Okay, so hello everyone. So in the last video that we did an equation of a secant line, and now we are going to do equation of a tangent line. I only did one example in the last video because, to be honest, it's really not that hard for secant lines. It's literally just finding the slope between the two points that they give you at the interval, and then finding the equation of those 2 points. Like, it's literally what we've been learning in Algebra 1, Algebra 2, college algebra, wherever you are. If you're in college, it's college algebra, or intermediate algebra, beginning algebra. So I only did one example in that video, but I went over it and I also just tried to explain what a secant line was, in a very detailed way, because I really wanted us to know what that is before we went into tangent lines, because tangent line is something different, okay? And sometimes the two can be very mixed up very easily. So I really want to, so that's why I didn't do both of them in one video. This video is going to focus on tangent lines. So a tangent line is different, okay? And like I said, I believe I went over this in the very beginning of this YouTube series of Cal 1. Now, like I said, when we have a curve, let's just kind of draw a random curve, doesn't matter. When we have a curve, I basically had said that between 2 points, it does not matter where on the graph they are. So like, one can be there and then another one can be over here. This is what we call a tangent, or a secant line, you see. Oh my, I almost confused myself there. So that's what we call a secant line. It's not drawn to scale, I will say. So basically, let me just draw a better graph. So let's say there's one point here, and then let's say another point is like, I don't know, over here. Or let's do this point here, and then this point over here, okay? The secant line is this, okay? It's the following. It's like this. And you have to make sure it goes through those 2 points. And this is just review of the last video very quickly. Oops. Like that. That is a secant line. So if I kind of color code that, I'm just gonna make it this color. So give me 1 second, guys. So that is what a secant line is, okay? So basically, like I said, it is just the slope between 2 points on a curve, or the equation of between 2 points on the curve. A tangent line is a little more tricky, okay? A tangent line is more, so let's see. Hold on. The best way that I can explain what a tangent line is, let's just, I don't know, let's draw some kind of curve. let's pretend that we just have a curve between two fixed intervals, right? And I want to find the equation of the tangent line, or the tangent line at this specific point here, right? I want to find the tangent line. So the tangent line is, it is basically, and let me just try to fix this a little bit better. This is why I don't like this one note, because it's really weird. This line here, let me change the color of this. This is called a tangent line, okay? And this, and if we kind of like, I don't know, if we kind of recreate the graph, like that, or the curve, obviously the tangent line will cross again, maybe over here, as it keeps going. But you want to look at whatever part of the graph, like whatever specific point it looks like it's about to touch, but it doesn't. Like, or actually it does, but there are two parts here where it looks like it touches it, and then it keeps just going and going and going and going. And then on the other side as well, it from the left and right hand sides, it looks like it just keeps getting further away again from the graph. That's the best way I can define a tangent line. I mean, I'm sure that in geometry, maybe they did teach, or if you've ever taken geometry in high school, they've taught what a secant line was versus a tangent line, with maybe with a circle, right? So I believe that in geometry, the way that they taught what a secant line and a tangent line was this way. So basically with a circle, if you look at a circle, and let's say we label a point on the circle, that means that this point, or this line here, is called a tangent line. This is where I believe you learn these when you learn about circles in geometry, where you learn about how a chord, when you learn about a chord, you learn about, like, this is a chord, and then you learn about how between any 2 points, let's say this one and this one, this is what we call a secant line. Okay, so that's the thing. It's the same thing in calculus, except, in calculus is more, it's more with other types of equations. So for example, like if I have, I don't know, a curve like this, and I want to find the slope of the tangent line here. So basically, let's say I have that curve there, and I look and I see, okay, this is considered, and it's not drawn to scale, by the way. I'm trying my best to draw it, but this is what we call a tangent line. Okay. And I believe in the last video I already went over secant line, but let me just very briefly explain what the secant line would be. The secant line would be something between this and this. So it'd be between that point and that point. So when you join them together, they look like they're almost the same line there on that curve, but as you get further and further in, they're not. I really wish I had a ruler to make this more clearer to see, but I don't. But anyways, we're now just gonna go ahead and so that is how the graphical definition looks of a tangent line. But now we want to go ahead and find what this equation is. What is the equation of this line, right? In geometry, we learned that yes, that's a tangent line, but now in calculus, we want to learn, well, between a curve, any curve, it doesn't matter. It can be a curve like this. It can be a curve like this. It can be a curve like this. At a specific point on the graph, what is the equation of this versus, instead of just knowing between 2 points, what would be this? But that is what secant is. This is what a tangent line is. So let's get started. So to start with this, and now that I've finally went over the graphical representation and the basic definition, we are going to do some problems that involve equations of tangent lines. Now, I'm not going to do equation of normal lines because I'm not 100% sure on how to do those. So, I mean, those I'm not going to go over in this playlist or this series of calculus, but I will go over tangent lines. So let's see. Let's say we had the function, and give me 1 second, I'm going to look at my notes very quickly. So let's just do this one, because this is one of the easiest ones. It's pretty easy, it's not that hard. So this one says, so find the equation of the tangent line at 1, 1. Okay, f of x equals square root x, right? This is pretty easy. So the way that we define the equation of the tangent line is the following. Y minus y1 is equal to f prime of x1 times x minus x1. Now, we know that this is x1, y1 because it is the only point that we have, right? Now we want to find, so we know what y1 is. y1 is equal to 1. We know x1 equals 1. We want to find what is f prime of x1 and what is, well, yeah, basically, we just have to find what f prime of x1 is. So what is f prime of x? The derivative of f of x. Well, if you've been watching my videos, the way that you do it is always just 1 over 2 square root x. And how did I get that? Well, we know that the square root of x is x to the 1/2. We do power rule, 1/2 to the x to the 1/2 minus 1 power. This gives us 1/2 x to the negative 1/2. So then that's going to be equal to 1/2 x, and then we have, so we want to turn x to the negative 1/2 to exponential form. That's going to be the square root of x to the negative 1, which is equal to the square root of 1 over x, which is really just the square root of 1 over the square root of x, which is really just 1 over square root x. Now, as far as this is concerned, this is going to be times 1 over square root x. So it's going to be 1 over 2 square root x. So that is a derivative, is 1 over 2 square root x. Now, we want to find that the derivative at x equals 1. So what is f prime of 1? Well, that's just going to be 1 over 2 times the square root of 1, which is really 1 over 2 times 1, which is 1/2. So that is this. That is what f prime of 1 is. Now, finding the equation of the tangent line, we have y minus 1 equals 1/2 times x minus, and we have times 1, because that's what x1 is, right? So this gives us y minus 1 is equal to 1/2 x minus 1/2. We add 1 to both sides. That means that y is equal to 1/2 x. And then negative 1/2 plus 1, that's just 1 minus 1/2. So it's going to be 1/2 x plus 1/2. Now you can write it like this, or you can also write it like y is equal to 1/2 times x plus 1. This is really y is equal to x plus 1 all over 2. You can write it this way as well. That is the equation of the tangent line. And we can prove that using Desmos, right? So if we look on Desmos, if we graph the square root of x, and then if we look at the equation of 1/2 x minus 1/2, or was it minus? Hold on. Plus 1/2. We can see that so here we can see that at 1, 1, this is the equation of the tangent line. Okay, we're going to do a few more examples. So let's see. Let's do f of x equals x square root x at x equals 4, okay? Now the equation of the tangent line, again, is y minus y1 equals f prime of x1 times x minus x1. So that's going to be, so at x equals 4, we want to find what f of 4 is. It's going to be 4 times the square root of 4. That's going to be 4 times 2, which is 8. So that's what f of 4 is. That's y1. Okay. So really, our point is 4, 8. This is x1, y1. So that means that we're going to have y minus, and y1 is 8, so minus 8 is equal to f prime, and we know that x1 is 4 times x minus 4. Now what is f prime of 4? F prime of 4, if we do f prime of x, and f of x equals x square root x, you can use either product rule or power rule. You can write this as x times x to the 1/2. This gives you x to the 2/2 plus 1/2, which is x to the 3/2 power. Then you can do 3/2 x to the 1/2 power. This is really 3x to the 1/2 power all over 2. And if you rewrite it in square root form, remember, the nth root of a raised to the m power is equal to a to the m over n power. So then this is going to be 3 times the square root of x over 2. Because it's to the first power, so it's just x. So f prime of x is really just going to be equal to 3 square root x all over 2. I believe that's what it is. Hold on. Give me 1 second, guys. Okay, so this is 2 ways that I did it. I did it using power rule, and I did it using the product rule. This part is doing power rule, so let me highlight it very quickly. So, this is using power rule. I found the derivative of x to the 3/2 using power rule, doing this, and then converting it back to square root method. And then over here, I did it using product rule. So over here was where I did it using product rule. So you can use whatever rule you want. These are just 2 different ways in which you could have done it to find the derivative of x square root x. So basically x square root, so f prime of x for this one is 3 square root x over 2. And f prime of x, let me actually look for... So f prime of x, we have f prime of, and it was at x equals 4, so f prime of 4 is going to be 3 square root of 4 over 2, which is 3 times 2 over 2, which is just equal to 3. Oops. So, in reality, you can just say that, so that's f prime of 4, so f prime of 4 is 3. And you can put it into the formula. So we have, so far we have y minus 8 equals f prime of 4 times x minus 4. And f prime of 4 we said was 3. So y minus 8 equals 3 times the quantity x minus 4. So this would be in point slope form. Now in slope-intercept form, you just have to add 8 on both sides. You have y is equal to 3 times x minus 4 plus 8. You do distributive property over here. You have 3x minus 12 plus 8. And you get y is equal to 3x minus 9, or minus 4. And that's how you do it. Let me see another example. So, let's see. Give me 1 second, guys. So let's do this one. This one is interesting. Hold on. Oh my goodness. Okay. So this one, we want to find the equation of the tangent line at x equals 0. Now, the first thing that you have to do is find f of 0. What is f of 0? So number 1, find y1, or find y1, and I'm going to say this, which is f of 0. Like this notation here, I'm just going to use that as like they're the same thing. F of 0 is equal to y1. So you're going to find f of 0, so you're going to say 3 cosine of 0 plus 2 times 0. So f of 0 is 3, and the cosine of 0 is 1, and then plus 0. So f of 0 is equal to 3 plus 0, which is just 3, right? So then you write the equation, so write the equation, or write the formula for the equation of, let me make sure that it's recording, okay, of the tangent line. This one is going to be, so it's going to be y minus y1 equals f prime of x1 times x minus x1. So then we have, so that's the equation of the tangent line, and we know that f of 0 is y1, so y1 is f of 0, or y1 is 3, excuse me. And then we want to find what f prime of, so number 3, find f prime of x. So what is f prime of x? We have f of x is equal to 3 cosine x plus 2x, right? F prime of x is going to be, so it's going to be, so the cosine x, it's going to be 3 times d dx of cosine x plus, and then the derivative of 2x is just 2. So then we have f prime of x equals 3 times negative sine of x plus 2. So f prime of x ends up being negative 3 sine of x plus 2. And if we find at x equals 0, f prime of 0, so at x equals 0, f prime of 0 will be negative 3 sine of 0 plus 2, which is, so it's negative 3, and then sine of 0 is 0 plus 2. So then we have f prime of 0 is equal to 0 plus 2. So then it's going to be f prime of 0 equals 2. One of the things you must remember is that sine of 0 is 0, cosine of 0 is 1, okay? At least remember that. I mean, you don't really do, at least I don't think you do a lot with, like, with trig functions when it comes to the equations of tangent lines, unless it's, like, inverse trig functions, which those are different. But, Yeah. So f prime of 0 is 2, so then we have y minus, and we know that y1 is 3 equals, and then f prime of x1 is just f prime of 0. So this is f prime of x1. So it's going to be 2 times x, and then x1 is literally just 0. So we have y minus 3 equals 2x minus 0. So y minus 3 equals 2x. We add 3 on both sides, we get y is equal to 2x plus 3. And if I graph this equation, 3 cosine x plus 2x, if I graph it on Desmos, so and then I say, and then I go ahead and just plot the point at 0, 3. So that, because that's f of 0 is 0, 3. So basically f of 0 is 3. So the point is 0, 3. So this is right here where 0, 3 is. And let me take this other stuff off. So then the equation of the tangent line, if I put 2x plus 3, you can clearly see, if you really zoom in here, you can see that this is the equation of the tangent line at this point. And so I am correct. The equation of the tangent line at that specific point is 2x plus 3. Let's do one more, and this will be it for this video. We have f of x equals e to the x squared over x at x equals 2. So find the equation, and the equation of the tangent line at x equals 2, okay? Sometimes they're going to give you x values, other times they're going to be a little nicer and they're going to give you the whole point. But when they give you the x value, just plug in 2 for x. So number 1, find f of 2. So f of 2, that's going to be e to the 2 squared power over 2. That's just e to the 4th over 2. Let's leave it like this. Do not simplify it. So basically, do not simplify. Unless they tell you to do so. Do not simplify that. So number 2, you're going to do find f prime of x. So we know that f of x equals e to the x squared over 2 over x, excuse me. So basically we have, so f prime of x will be equal to e to the x squared prime times x minus 1 times e to the x squared all over x squared. So f prime of x will be equal to, and we have to find e to the x squared prime. This is a double chain rule. Let u equal x squared, and so u prime, if y equals e to the x squared, u prime is going to be 2x, and so basically we have, so basically it's going to be e to the u, and the derivative of e to the u is equal to e to the u times u prime. So basically this is going to equal e to the x squared power times x squared prime. So this is going to be equal to e to the x squared times 2x, which is 2x e to the x squared. So that's f prime of x, or, hold on. That's, so let me, oh my goodness. So that means that e to the x squared prime is equal to, 2x e to the x squared. So that means that f prime of x is going to be 2x e to the x squared, and then times x minus, and then 1 times e to the x squared is just e to the x squared. And then you're going to do all over e to the x, or all over x squared, excuse me. So then, and you use quotient rule for this, by the way. If you don't know how to do quotient rule, I have a video on that on the playlist of calculus 1, so you can look at it. But you have f prime of x is equal to 2x squared e to the x squared minus e to the x squared all over x squared. So then this simplifies to f prime of x equals e to the x squared times 2x squared minus 1 over x squared. Now, we can keep it like that. It's okay to keep it in factored form, because really it doesn't matter whether or not we have it like foiled or factored. We're still going to find f prime of 2 because of the equation of the tangent line, right? So basically at x equals 2, f prime of x will equal f prime of 2, which will equal to e raised to the 2 squared power times 2 squared minus 1 all over 2 squared. This is going to equal to e to the 4th times 2 times 4 minus 1. 2 times, so it's basically times 2 and then times 4 minus 1, right? And then we have over 4. So this is e to the 4th times 8 minus 1 all over 4. This is e to the 4th times 7 all over 4. So this is 7 e to the 4th over 4. This is what f prime of x1 is. So basically, f prime of 2 is equal to 7e to the 4th over 4. Now, list all components of the equation of the tangent line. What I mean by that, and I'll explain what that means in just a second. What I mean by that is, you need to list what x1 is, y1 is, what f prime of x1 is, and basically, yeah, so basically you're going to rewrite it. Y minus y1 equals f prime of x1 times x minus x1. We know that y1 is equal to e to the 4th over 2. That is y1, because that's what f of 2 is. So y1 is e to the 4th over 2. And then, how do I say it? Then, f prime of x1 is just f prime of, and then x1 is just 2, because again, it's saying at x equals 2, so it's f prime of 2. So that means that this is equal to 7e to the 4th over 4. And then x1 equals 2. Because like I said, like this, right? So putting all of these in, f prime, so we're going to have the following. Y minus e to the 4th over 2 equals, and remember, f prime of x1 is just f prime of 2 times x minus 2. And then f prime of 2, if we rewrite f prime of 2 equals 7e to the 4th over 4. We can use, we can use let's see, hold on guys. I'm trying to see if there's another color to use. So, this is f prime of 2. Okay, so then we have y minus e to the 4th over 2 is equal to 7e to the 4th over 4 times x minus 2. You can simplify this. This is in point slope form. Now, if you want to get it to slope intercept, what I recommend first is that you add e to the 4th over 2 on both sides, so that's going to give you y is equal to 7e to the 4th over 4 times x minus 2 plus e to the 4th over 2. So then we have y is equal to 7e to the 4th, so it's going to be 7x e to the 4th over 4 minus, and then we have 7e to the 4th over 4. So basically it's going to be over 2 times 2, because that's what this is, and then if we do times 2 here, we can cross these two out. And then we have plus e to the 4th over 2. So then this is going to be y is equal to 7x e to the 4th over 4 minus 7e to the 4th over 2 plus e to the 4th over 2. So this is going to be y is equal to 7x e to the 4th over 4 let me just make sure I did it right. Hold on. Okay, so yes, I'm right. So here it's going to be minus, and then you have 6e to the 4th over 2. So then you have y equals 7x e to the 4th over 4 minus 3e to the 4th. And you can rewrite it as y equals 7e to the 4th over 4x minus 3e to the 4th. And, oops, that's not what I wanted to do. So this would be your answer for this one. Okay, guys, that is it for this video. I'm gonna, I'm gonna post this on YouTube, so that is it for this video. I don't want to go even further with this, because, like I said, this was just, I feel like the last one that I did was more of a harder one. But if anybody has any questions, please let me know. And in the next video, what we're gonna do, let me see, give me 1 second. Okay, so in the next video, what we're gonna do, we're finally gonna get into implicit differentiation, which it's another kind of, it's you use like quotient rule, you use all your rules, but it's more in terms of x and y, and you're finding the entire derivative of that with respect to x. So yeah, that is going to be in the next video. And after that, we are going to get into actually finding like more applications of derivatives, which is going to be more like related rates and you know, finding concavity and maximum and minimum and increasing and decreasing intervals, etc. So please stay tuned for that. Like that's it, you know, that's going to be in the next few videos. But with that being said, guys, thank you so much for watching. If anybody has any questions, please let me know down below. Please like, comment, and or subscribe. And I will see you guys in the next video. Thank you so much, guys. Bye-bye.